This is the brief on dimensional analysis in physics. We're diving into how dimensional analysis can successfully predict the functional form of physical laws. We're going to use the spring mass system as our example, and also pinpoint the one thing this really powerful technique just can't tell us. Okay, so first, dimensional analysis accurately determines the necessary functional form of the physical law. For the period of that spring mass system, the technique establishes that the period has to be proportional to the square root of the mass divided by the spring constant. This correctly captures that nonlinear relationship where the period gets longer with more mass or a stiffer spring. So how does it do that? Well, second, the core method uses a system of linear equations derived from fundamental dimensions, mass, length, and time. By making sure the dimensions on both sides of the equation balance out, we can solve for the exponents and find exactly how the mass and spring constant are related to the period. Finally, there's a fundamental limitation. Dimensional analysis is unable to determine any associated dimensionless constant. So while the technique proves the relationship must take a certain form, the actual numerical value of that constant has to be found separately, either through some rigorous analytical modeling or by running precise experiments. So, dimensional analysis is a powerful shortcut for defining variable relationships, but it always leaves that crucial dimensionless constant for experiments or deeper theory to figure out.